Assalamualaikum and hi, my name is Nosha Zana binti Cik Zakaria and my matrix number is 19DIT24F1133. My part in our project is inheritance and exception handling.
Hi, my name is Nur Azza Afira binti Izam. My number matrix is 19DIT24F1053. My task in this project, develop the main class and present the system demo.
My name is Nur Najwa binti Hairul and my matrix number is 19DIT24F1009. And my part on this project is I do a code for number 1, class and object, and number 2 for array list.
Assalamualaikum and good day everyone, and I will be presenting the first part of our mini project titled Student Course Registration System. Our project was developed using Java programming language and apply object-oriented programming concepts such as classes, object, inheritance, and exception handling. First, for the course class, it includes 3 main attributes: course code, course name, and credit hours. A constructor is used to initialize this value, and each course can be displayed using a simple print method. This represents the class and object concept, where each object created represents one real course. Next, for the student class, we use an array list to store multiple course objects that are student registered for. The method used are add course, remove course, and display course. This method allows a student to manage their course registration dynamically, meaning they can add or remove as many courses as needed during runtime. Through this part, I learned that array list is very useful for managing data collection in a flexible way. Now, I will pass to the next presenter to explain the inheritance part of our system.
Thank you, Najwa, and hello everyone, and I will be presenting the inheritance part of our project. In our student course registration system, inheritance is used to represent different types of students. We create 2 subclasses: undergraduate student and postgraduate student. Both classes inherit from the main student class. This means they share the same structure and methods as the parent class, such as adding, removing, and displaying courses. However, each subclasses has its own specific rule. The undergraduate student class can only register up to 5 courses, while the postgraduate student class can only register up to 3 courses. This difference is implemented by overriding the add course method in each subclass. When the number of courses exceeds the limit, the system will stop adding and show an error message. This demonstrates the OOP concept of inheritance and polymorphism, where a subclass can reuse and modify the parent class behavior to suit its own needs. Through this part, I learned that inheritance helps us reduce duplicate code and makes the program easier to maintain and expand in the future. Next, I will be explaining the final part of our project, exception handling and system demonstration in our program. We use exception handling to manage invalid operations gracefully. For example, if a student tries to register more courses than allowed, the system will not crash. Instead, it will show an error message like undergraduate max 5 courses or postgraduate max 3 courses. To make this possible, we create a custom exception class called course limit exceed exception. This exception is thrown inside the add course method and code in the main program using a try-catch block. This ensures that the system continues to run smoothly even when an error occurs. Next, I will pass to Azah to explain the next part.
Next, I'll be explaining the final part of our project, exception handling and system demonstration in our program. We use exception handling to manage invalid operations graphically. For example, if a student tries to register more courses than allowed, the system will not crash. Instead, it will show an error message like undergraduate max 5 course or postgraduate max 3 course. To make this possible, we create a custom exception class called course limit access exception. This exception is thrown inside add course method and called in the main program using a try-catch block. This ensures that the system continues to run smoothly even when an error occurs. Now, we will demonstrate how our student course registration system works. First, we compile the Java program to make sure there are no syntax errors. After successful compilation, we run the program to start the system. When the system runs, it welcomes the user with the title Student Course Registration System. The system first asks for the student ID. So here we enter the matric number. Next, the program asks for the student name. After entering the name, we are required to choose the type of student. There are two options. Undergraduate represented by number 1 and postgraduate represented by number 2. In this demo, we will select number 1 for undergraduate. After that, the system displays the main menu. For the first option, we choose to display the available courses. There are 8 available courses shown, which are Programming Fundamentals, Database System, Networking Concept, Object-Oriented Programming, Web Design, Discrete Mathematics, Operating System, and Problem Solving and Program Design. Next, we will add course to the registration list. We select the option Add Course. Then enter the course for each course. First, we add DFC 2013. Then, followed by DFC 1023. Then, DFT 3013. Then, DFP 2023. And lastly, DFB 1012. After adding these 5 courses, the system confirms each one as successfully added. Then, we try to add the 6th course, DBM 2053. However, since this is an undergraduate student, the system displays an error message. Undergraduate students can only register up to 5 courses. This shows that the system correctly enforces the limit for undergraduate students, while postgraduate students are limited to 3 courses. After adding courses, we choose the option to display registered courses. The system then lists all the 5 courses that have been successfully registered, including their course code, course name, and credit hour. This feature helps students and administrators easily review the registered course. Now, we will demonstrate how to remove a course. We select the Remove Course option and enter course code that we want to delete. The system confirms with the message course removed successfully. If the entered course code doesn't exist, the system will show course not found. This proves that the system handled invalid input properly. Finally, we choose option number 5 to exit the system. The program displays the message exiting system. Thank you. This is the end of our demonstration. To summarize, our system allows students to register, display, and remove courses efficiently. It is also enforces course limit based on the student type and handle error in a user-friendly way.
For the data protection and privacy part, our group focused on 2 main ways to protect sensitive data in the student course registration system. The first method is data encapsulation. In the student class, all important information such as student ID name, and the list of registration costs are declared as private attribute. This means the data cannot be accessed or modified directly by other classes, only through gather and setter method. By doing this, we ensure that all student information remain confidential and secure from unauthorized access. The second method is exception handling for system security. We create a custom exception called course limit exceeded exception. This exception will be triggered if a student tries to register for more than the allowed numbers of courses. For example, undergraduate student can only register for 5 courses, while postgraduate student can register for 3. This helps the system prevent invalid operation and ensure the data remains consistent and protected from misuse.
For our originality and integrity, our group makes sure that all coding and design are created by ourselves. We develop the whole system based on our own understanding of object-oriented programming concepts such as inheritance, encapsulation, and polymorphism. We only use an AI and documentation for learning reference, not for direct code copying. This ensures our project is original and reflects our real understanding. We also add comment in our code to explain each part clearly, showing that we truly understand how our system works and that it was ethically developed without plagiarism.